Hello and good morning, everyone. Welcome to Coffee and Compressed Air. Today, I am very excited to have Chad here from AirPipe. Chad, I'll give you a second to introduce yourself and what you do.
Yeah, thank you, Danny. Yeah, thanks for having me. And then cheers for the
Yes.
cup of coffee here. It's still early on the West Coast.
Mhm.
And then yeah, thank you for having me today. I've been enjoying these series that you've been hosting.
Oh, good.
Yeah, thank you for putting out this type of education. Reaching out to those knowledgeable in the field. I don't
Mhm.
claim to be one of the most knowledgeable in the field. I will say that I do have, 15 years experience within the industry. Prior to that, I worked in hydraulics and
Okay.
found my niche in compressed air. Have really enjoyed working within the industry, educating those about systems, because there's a lot that most people just don't understand. You've
Yeah.
encountered it. How
Yes.
everyone thinks that it's so simple. If machines are running, if air is coming out, then it's working, right?
Right. Yeah.
So
Definitely. Definitely. Yeah. Compressed air, the system is so complex, mainly because there's so many moving parts and it's in so many different types of industries that have different needs of the compressed air as well. So I am very interested in this talk because most of the other components I'm a little familiar with. Like I know what valves do. I know this. I honestly never put thought into the actual piping other than it should be sized the whole way from the compressor to the endpoint in order for the air to get there. So I'm very interested to see what else is going on in the air pipe world that we should know about.
sure, yeah, yeah, good segue because the company that I manage is called Airpipe. It's in the name. That's what we do.
Yeah. Also, I don't know how you got that name. Like, how did you actually get the name air
So
pipe?
I did go to college with a friend that works within the government, especially within the patent office. And so, again, being educated, you know,
Yeah.
and having some
So
connections.
interesting.
But
Yeah.
yeah, we
So
were very
interesting.
lucky to gain that name with the United States government. But we're also a global company. I mean, we had that coming in. Airpipe's been around for 25 plus years globally. We did enter the U.S. market in 2015. So
Okay.
officially enter the U.S. market. Started the business here in 2015 when you had a lot of companies were starting to learn about what we specialize in, which is aluminum piping technology. And we'll talk more about the advantages of that
Mm.
during this informative session, we'll call it. But I wanted to focus mostly on you know designing the system for new and old
Mhm.
systems, looking at what is the real cost of energy, becoming energy aware, and then really what are the basics that someone needs to focus on when they're designing a system, because
Mhm.
it's not as easy as you just purchase a compressor, hook up hose or piping to said tooling. That works for a private workshop, and
Mhm.
that's fine. But when we're talking about industrial facilities and factories, it becomes quite different. And it can be complex. That's why we have such a diverse industry. We have those like me that are doing the piping, and I'd like to call us, we're the great connector. And we're friends with everybody because you have to use something to connect
Yes.
all of the equipment, compressors, tanks, dryers, filtration,
Mhm.
all the different tooling that it goes to. We're involved with everyone. So I guess we're the great networker.
Yeah, that's really perfect. That's an interesting way to put it. Because normally it's like, okay, distribution, like we think of the supply side, distribution, and then demand. So, but
Yeah.
yeah, it
We dance
literally
in both.
connects the whole thing. Yeah, perfect. So you wanted to touch on the design aspect, which could be overwhelming for someone who's, I mean, you have a blank canvas, you have a massive warehouse that you're starting with. Like How do you even go about that?
Yeah, yeah. I would say any new facility, and there's a lot more awareness that's happening, but you
Mhm,
need to get a true engineering firm involved. And when you have a new system, the very first thing you want to do when you've got engineering involved in setting up your facility is you need to
mhm,
set up what is your basic demand profile, and what does that mean? Then in its most basic terms, which I'll try to touch on basic terms here, to bring awareness for the audience.
mhm.
And majority of tooling and equipment is all sized by, everything's calculated with an average of 90 psi. So to run a piece of equipment or tooling, we need pressure and we need flow. And so designing for equipment, they'll have the standard variable of 90 psi, which will then give us our flow, our SCFM. And so what that states is in any minute, that's how much flow of compressed air we can introduce into that piece of equipment. And that is the key, the flow. If you can take
Mhm.
and measure all of the equipment, all of the consumers, we call them, and add that up, then that'll tell us at any given time how much total SCFM does our system need, keeping in mind that it's typically operating on an average of 90 psi.
Okay.
And once you have that, you can then start designing your system from and I'll call it your generation equipment, which would be your type of compressor.
Okay. Interesting. So what is one of the most common mistakes that you run into that you see most often? If somebody's calling about air pipe, what are they calling about?
Well, the biggest thing for anyone is, what size pipe do I use? And that's
Mhm,
that's really one of the main reasons why we're talking today. How do I know? And it's not easy. That's why we need to have engineers involved that can work with the factory owners to determine, we've got our demand profile, and we need to figure out what type of equipment we need to then purchase for that. And I'm not even getting into air treatment yet. I will shortly.
mhm,
But if you have this information, then you can work with an engineer that can help you decide what size of piping I would need. And it's not so simple as it's the same size piping throughout the entire facility.
mhm,
So if I had to break it up into a very basic map, or basic diagram, you would have your compressor, and let's, in this case, we'll just say one compressor. We don't have multiples chained. We don't have redundancy. That
mhm.
compressor ideally would then produce air, compressed air, and then we would want to put that to we call it a wet tank. We like wet tanks because it helps it helps water naturally condense out of the air without using any other type of equipment. That's a nice vessel for that. From the
Okay.
wet tank, from the wet tank, we can also start going down the line, and keep in mind, we're still in our compressor room, we call it. We're still on the supply side. You're going to need to have, you want to have some filtration to help clean that air. You're going to want to probably have some coalescing filtration to help bring out some oils that could be present in the air. Because keep in mind, all a compressor does is it takes whatever air is outside of it, wherever that air is being sucked in, it is
Mhm,
going to compress that. And so you might not think there's oil in the air, but I've worked in plenty of factories where you you see the oil, especially in metal cutting
mhm.
facilities. A compressor will draw in ambient air and condense that down to where you'll have liquid oil flowing through the system, just like
Oh,
moisture,
wow.
liquid water. There's
Mhm.
humidity in the air. It condenses all of that down and then magnifies it. And so you have filtration is needed for that. And then you have your dryers. You're going to want to, you have different types of dryers. That is a whole nother session, depending
Yeah.
on the applications you need it for and
Yes.
where your factory is located. Are you in a particularly dry environment? Is your factory in an area where you've got large temperature fluctuations? If your factory is not, if your energy room, compressor room, or factory is not climate controlled,
Mhm.
so you've got your dryers that are coming out. Dryers are then going to potentially increase the heat. So now you've got temperature involved coming out of the compressor, because generating compressed air produces heat. And so you've got to make sure that you've got the proper seals in place for that, for your piping system or any other piece of equipment. And so here we are flowing all the way through from the compressor. We leave the dryer, and then we want to have a receiver. So we'll call it a dry tank. So this would be a large receiver that, again, has to be sized correctly for your factory. And then you've got a pressure flow controller there that will then, what it does is it controls the flow of pressure out to the demand side of the factory. And so explaining all of that, if it sounds like a lot, it's because it is. And that's why we have so many individuals involved in this industry, because they focus on each of those to help you size your system, not just the piping, but your equipment appropriately. And something that is a good, like some good rules of thumb. And so write this down this is something to write down. I like to think in terms of velocities. So we typically measure velocity in feet per second. And good rules of thumb that I follow are going to be, when I'm dealing with inside the compressor room, I don't like to see velocities go above 20 feet per second. 20 feet per second. 20 feet per second is a decent velocity. And the reason why I like that is because it's keeping the velocity is not reaching a point to where it's creating chaos inside the system. It's keeping your flow profile, your pressure and flow moving relatively stable. And that's in your compressor room. We don't want to exceed 20 feet per second. Once you get into your main header piping throughout your facility, we don't like to exceed 30 feet per second. And if you start getting into drops, once you leave your header, you're going into your drops, we never want to exceed 40 feet per second there. Ideally, I would never like to exceed 30 feet per second anywhere on the plant floor. The reason for that being is that once you start going above 30 feet per second, velocity is traveling fast enough that you can have liquid water entrained in the air, which means when you have drip legs installed in your system to help, you can try to prevent moisture as much as you want, but you could have an event where your dryer hasn't been maintained properly, or your dryer goes down, or maybe you didn't size your system properly, you didn't get the right dryer. So many variables can happen to where moisture oil could be in your system. And so you try to design a system with drip legs, or you have what they would call the up, over, and down for drops off of your header. So you're essentially pulling air from the top in case there is any liquid in the system. You wouldn't want to have it at the bottom where liquid would just flow straight down, unless you're developing a drip leg for that. And so if your velocity is too high, that drip leg may not help you. It won't be as efficient, because that entrained, it's traveling so fast that it's picked up the liquid and it's carrying it with it. So it could bypass, it's going so fast it could bypass even some of your filtration to go into a bypass if you're going into very high velocities, depending on the type of filtration you have. And then 50 feet per second, I've heard it before. If you can hear the compressed air going through your system, that's bad. And because what you're hearing, you're literally hearing we don't see air molecules, but they're there. And when we compress them, they're getting tightly together. So it becomes literally, think of it like a fluid. Think of it as a tangible matter, because it is. And so when you hear it flowing down through a piping system, it's literally hitting the walls of the pipe, bouncing around, scraping against the metal. Like, that's what you're hearing. You're hearing the sound of the air as it's going through, like the whoosh is what we call it. So those air molecules are bouncing off each other, and it's producing sound.
Interesting. Okay, so this leads perfectly into my big question, which I'm sure a lot of people have, and this would be, from my perspective, one of the biggest misunderstandings. What about I'm just building a facility, I may add machines later. I'm just gonna oversize. I'm just gonna get the biggest pipe possible for my header. Is there downsides to that? Or like what is the effect there?
Yeah, you're right. So yeah, I mean, the bigger concern is undersizing, choking off my system,
Mhm.
incredibly
Okay.
inefficient, or worse, I don't if the system's too small, I can't physically get enough air to equipment and it doesn't work.
Right.
And so
Mhm.
what if I just be, I don't want to do all the math and I've got deep pockets and I just want to put a big old.
Yeah.
So yeah, the major downside with that is you still run the risk of starving out your system because what you've done is you've created such a large area to fill with compressed air
Mhm.
that what's going to be very expensive for one, super inefficient. And if you can't fill that vessel, which is too large potentially,
Mhm.
then you still won't be able to provide pressurized air,
Okay.
definitely not efficiently, but you may not be
Mhm.
able to provide. And then you've got to buy, so therefore you've got to buy more energy producing compressors.
Mhm.
Fill that
To
void.
fill up that space, yeah.
Yeah, I mean the
Okay.
major thing is it becomes very, very expensive, which um, I don't know if you planned this, but it seems like a really good segue into the energy costs of compressed air.
Uh, Look at that.
I mean,
Perfect.
I swear, everyone, we did not meet before this. This is happening. This is happening organically. Um, and so, I mean, I've noticed I have watched on some of your other sessions that
Mhm.
the cost of compressed air is a big deal, and
Yes.
it's because, and here's the reason why it's such a big deal. Those of us within the industry, we well know that. The
Mhm.
key is educating facility owners about it. And you would be, I mean, I was shocked when I started going to facilities. First off, I'd ask people, maintenance managers, do they even know what the power bill is for their factory?
Mhm.
No, they
No.
don't even know because they said everything's working. I don't care.
Mhm.
No one's come to me to complain about that. Uh,
Mhm.
so again, back to awareness. But I mean, this information comes directly from the Department of Energy.
Mhm.
Yeah, 75% of facilities, they don't know what it costs to generate compressed air.
Yeah.
And they don't know how expensive it is. And
Mhm.
that goes right into the fact that, I mean, 30% of all of the energy used in a typical industrial facility is just to generate compressed air. So
Yeah.
30% of a power bill, to put that into perspective, I visited a factory within the last few years when we were doing a study on energy consumption. And I asked them, I said, how much do you think you spend on compressed air to generate compressed air annually? And they said, I don't know, 25, $50,000. And I mean, it was over $250,000.
Oh, wow.
And they couldn't believe it. They,
Mhm.
they said, how is this not talked about more? And it's the same reason, like everyone knows that leaks are bad and
Mhm.
and people get leak assessments done. We've seen it all the time where they tag the leaks and they come back later, months, a year later, and those leaks are still tagged for
The
repair.
tags, yes.
But the problem always comes down to production downtime. It's
Mhm.
I know it's expensive, but my system's running. I
Mhm.
know it's efficient or inefficient. I don't know how inefficient, but that's the real reason is it's
Mhm.
scary once they learn just how inefficient and how expensive it can be to run these systems, which brings us right into, well, no, I mean, I'll throw out another fact from the Department of Energy. You know, for every 2 psi you can dial back on your
Mhm.
compressor generation, it's 1% energy savings on average.
Mhm.
One
Yes.
1%. Um, I mean, if you can pull up, I've got the slide that has the superhero on it. And
Yes.
I mean, this goes right into leaks. You can see that, the character there is holding a leak detector tool. And this
Mhm.
goes right into the importance of doing these regular checkups. Your compressed air systems, you need to think of them as organic systems. You know,
Mhm.
they they need regular checkups. Conditions change. Equipment does break down, and you need to know when that happens because the cost of it running inefficiently is a lot more than you think. And that's assuming you have no leaks. Like
Right.
assuming you have no leaks, like magically no leaks, you
Mhm.
still need to maintain and monitor your system for performance. But let's just quantify some leaks. I mean, I've seen
Right.
factories that have, we've tagged 100 plus leaks. And so, I mean, an annual cost here of, $1,000 times 100,
Mhm.
I mean, that's a hundred thousand
Yeah.
dollars you could have saved. And
Yes.
then, and that brings us back into the cost of a leak is more than just the cost of energy. Because I mean, just like you had a gentleman on recently that
Mhm.
discussed what happens when air is blowing, leaking out of a system. It's a strange concept to think about the Venturi effect, which
Mhm.
is, air's leaving my system, and the Venturi effect says that there's a vacuum created at that leak that then sucks in ambient air. It seems strange to think about that, but it is occurring. And
Mhm.
so you're losing money and pressure because the air's leaking, but you're also introducing now particulates, um, any ambient. Now, granted, it's not compressed ambient air, but it's still ambient air that you don't,
Mhm.
unless you're in a clean room environment, unless
Right.
it's environmentally controlled, you are introducing contaminants to that system.
Mhm.
Which, if you have, that's another case to have point of use controls in place once you get down to equipment,
Right.
because equipment nowadays comes with its own sensors inside that will tell the OEM if it has moisture sensors in there. It has
Mhm.
oil detecting sensors, particulate filters. If any of those are tripped, you very well void the warranty of the very expensive equipment, production equipment that you have on
Mhm.
that floor. And so those things need to be controlled. They're in
Mhm.
place to help with the quality production of your goods.
Right. Right. So we are over time, but I have one more question if anybody's still hanging around that so we're getting into these leaks. Can you speak a little bit on how piping and connectors can be involved in leaks? Is there a way to set them up properly or use certain materials that can make them last a little longer, or does it depend on the applications and what's going on there? Just what's your feedback from the piping perspective and
Yeah,
connectors on leaks?
yeah, I know. We did even get into the piping. Um, so real quick, I mean, on the piping, the designs that we have, we created them based on, our experiences and feedback globally
Mhm.
on what we were seeing. And so what we've created is a product that's modular. Uh, the aluminum technology inherently, no matter which manufacturer you're going with,
Mhm.
is a benefit primarily due to the weight. You've got weight savings and speed of installation, which
Okay.
every manufacturer of aluminum product is going to have the weight savings and a quicker speed of installation versus the traditional methods of installing.
Mhm.
That is now becoming the labor savings is probably one of the most popular items and growing right now because of the
Mhm.
cost of labor increasing, and then the ease of installation.
Mhm.
It does not require as skilled a labor as it traditionally has required for threading systems,
Mhm.
welding systems, brazing systems. And it's no surprise that we are in a lack of skilled labor right now in the United States. And so a system like ours, being easy to install, quick to install, is ideal. in today's industry. And then I'm not even incorporating the other benefits that come with it, expansion and contraction and vibration, which I
Mhm.
could speak on at another time. We use large elastomeric seals, not just O-rings, to make sure that we have that connection between the
Okay.
mechanical connections.
Mhm.
The system we have, it grips right, it bites right into the aluminum material with the fitting. And so you've got
Mhm.
a very strong mechanical hold, but then you've got a
Okay.
large surface area where we have elastomeric sealing that's occurring.
Mhm.
And that is what maintains the system integrity that we have. I mean, that's air
Okay.
pipe right out of the package is already ISO certified
Mhm.
8573.1.1.1. And all that means is that it's got one of the highest level ratings for keeping the air clean. So a pipe system
Okay.
is not going to clean your air, but an
Mhm.
ISO system with our rating will not introduce anything,
I see.
particularly because of it being leak free. And
Interest
that's a true benefit there.
Mhm.
I mean, another major benefit too is the reason why most maintenance teams don't typically repair systems or leaks is because they don't have the time. It's
Right.
expensive to cut out steel systems.
Yes.
With our product, you can do it in minimal time. If you need to add a drop, you can do
Mhm.
it. I've seen it done during lunch breaks. When the
Wow.
team leaves for lunch breaks, the team will go up there, drill the hole, install the saddle, and put the drop
Mhm.
in down to the piece of equipment, within an hour. And it's an incredible advantage.
Yeah, that's incredible. Incredible. Okay, perfect. We are over time. I'm gonna end there. I think we might be doing a part 2
Yeah,
in the
that's
future.
right. Stay
Yes.
tuned. I want to talk about the crazy concept of why does my pressure go down when I increase my velocity? Wild.
Yes, yes, that'd be very interesting. So stay tuned for that. Until then, you know how to reach us. Chad is linked in here, so you can put comments, ask questions, reach out to him or myself that way. Thanks, everyone.
Yeah. Thank you. Cheers.